So I'm starting the recorder. The audio is good on the recorder because someone told me that in one of my other classes, the audio was missing in one of the recordings. So I just want to double check first. All right. So a few things that are kind of important. The first one is if you are ready, if it is your turn already, based on priority level, to sign up for classes in the fall, do it. Don't postpone that. Okay, this is one of the things you really do not want to postpone because the classes can get filled up pretty quickly. So once you figure out your own schedule, because of your part-time job or family situation and whatnot, then it's time to go in and actually go sign up for classes. So as it stands right now, the next class, which is CISP 360, all three sections at ARC are still open. So we have three different professors teaching the three sections. The first one is Kakashine, and she is teaching they're all partially online, which means they're all hybrid classes. And in this case, this one is a Tuesday only class in the morning. And then we have Ryan Hermely teaching this class. This is an afternoon class on Wednesdays in the afternoon. And then we have Momena, who is teaching this class Tuesday only, also in the afternoon. So, depending on what day works out best for you, or you can also check out the instructors and see which one works best for you. I can tell you that they're all three are good. Okay, they're good in slightly different ways. I think Kakashan is no. No, Ryan is very technically competent, so he would focus more on the technical stuff. So I would say out of the three, Ryan probably resembles the way that I teach the most, focusing on fundamentals and stuff like that. Kakashine is a little bit more gentle, okay, in the sense that, she would actually, go slow, and explain the concepts a little bit more. Um, but there's still a lot of work to do. Momena is also she's newer, so in a sense, this is like her third time maybe teaching this class, which is actually not a bad thing, okay? Because new professors tend to have new ways of doing things and not, you know, in a bad way, okay? In a good way, innovative way, right? So those are your choices on ARC campus. You can also look into these classes offered, from a sister campus. But in the sister campuses, I think most of these classes are not. Um, they are more online only. So when you look into particularly Folsom Lake, I think they have a lot of fully online classes. Like when you see, oh, this one is in person. This is fully in person. Okay, well that's good. Um, the question is it going to fill? Partially online, partially online, partially online. Hmm? Yes. Hmm. Yeah. So at Folsom Lake, that's when you start to see fully online offering of these classes. Um, unless your only option is to take a class in a fully online fashion, like you really have time conflict with all of the other offering, I personally would recommend taking classes in person, especially a STEM class. If you're talking about maybe some of the GE classes where the content is not intense and you really do not need to be spending a lot of energy to understand the material, maybe you can take it online. But with your CISP courses, I typically want to kind of tell people to take it either hybrid or fully in person because having that structure in the classroom is actually important. And you can see the online classes are the ones that are already filled up. And I can kind of understand from the perspective of students, the flexibility of fully online is kind of nice because it won't be conflicting with anything, right? I mean, it's online and asynchronous, right? You can do your studying and your homework anytime you want to. But at the same time, unless you're very self-disciplined, which I am not, okay, I have the self-awareness to know that I'm not. then lacking the structure of I have to be in the classroom on certain days at certain times, and also having actual classmates in the classroom, that's part of your structure. So lacking that structure, taking classes that are fully online can be challenging. Okay, I know that I would not succeed in a fully online class. Okay, I need that structure in the classroom with people, and certain times, certain dates, and so on. All right, so that's the first thing. Second thing is what will be. Oh, right. I need to kind of remind people of the final exam. It is on the calendar already. Let me check. Yeah, I think it's the 19th, but I'm gonna double check to be sure. Um, if you have not done so, you can give it a try. I'll get to the calendar page and then I'll tell you what I mean by trying. And it's just taking a long time. There we go. So you are correct. It is on the 19th from 8 a.m. to 10 a.m. So you might want to put it on your personal calendars just so that you remind yourself that you have to be here 1 hour earlier than usual because the final exam starts at 8 a.m., not 9 a.m. All right, so let me show you a link down here. Oh, okay, I don't have to go that far. It's right here, calendar feed. So if you click on this link here, it gives you a URL, and you can copy this URL into Google Calendar or Outlook. Most people use Google Calendar. If you do that, it will show up on your Google Calendar. All the homework assignments, the final exam date, what time it is, it will show up on your calendar, which means it is more likely that you will remember to have a final exam. Our final exam is on the 19th at 8 a.m. if you do it that way. The problem is you cannot selectively say, I only want certain classes to be on my calendar. If you do this, then everything on your Canvas shell will appear on your personal calendar, which can be a lot of items. Okay, so all the due dates of everything is going to appear on your calendar, which I think is not going to be an issue. It's actually a feature, but some people do not like that many things on the calendar. All right. So having said all that, we are now moving on to the actual content of today's class. Um, I can let you guys choose, how we want to proceed, because I'm not sure whether I have shared this with you. Computer Science Job Outlook 2025. Did I share this with you? No? Do you guys want to see this? Okay. I thought so. All right. So this is my little conversation with ChatGPT, and I can share the conversation with all of you too, so you can read it on your own. I asked ChatGPT what is the job outlook for computer science students who will be entering their junior year. So that really does not apply to you guys. You guys are basically equivalent to freshman year. Quote statistics and the sources of the information. So basically, the trend is okay. There are high growth areas, data scientists, information security analysts, and software developers. But you can see how the first two they have a projected 36% and 33% of increase over 10 years, and the software developer is 17%. But AI is making an impact, which means you really need to know what is AI, or at least in the context of your job, what is AI, which is most likely just LLM or large language model in this case, and what you need to do in order to be competitive when you are entering the job market. So it describes entry-level job market. The trend indicates a decline in entry-level software engineering positions, with job openings decreasing by over one-third compared to 5 years ago. And I think this is going to be a trend that will continue. The contraction is attributed to increased productivity through AI and the competitive job market. It is also attributed to overproduction of computer science graduates, which is also not going to taper off, I would say, for another 2 to 3 years. Um, um, okay, so regional salary variation, report higher. So But people from Berkeley report higher median salary. 2 year post graduation UC Berkeley computer science alumni have a median annual salary of $150,000. I can tell you that's more than what I'm making, surpassing peers from other universities. So it may not be the university itself, okay? It can also be the connection from the university to industry. Okay, so you also have to keep that in mind. It's not like, oh, if I get into Berkeley, I'm going to guarantee to get a job that's going to pay me $150,000, once I graduate. That is not true. Okay, and that's not what this is saying either. It is simply saying from the statistical perspective, this is what's happening. And the recommendation, I can say that it's probably all true. Okay. The first one is develop AI and machine learning expertise. Well, you can start with understanding what it can do and what it cannot do. The what it cannot do is the more important part because that's why you are hired. If all you can do is what the AI can do, it's not a good thing. Okay, so you want to find out what AI cannot do and then develop your expertise based on that. Gain practical experience. So internship is a really big thing. Um, if you cannot get into an internship, at least do some personal projects where it is verifiable when you get into an interview. Okay, so instead of just saying, "Oh, I got 20 projects and it's all about this and that and whatnot," so instead of doing that, make sure that your projects are trackable. And one way to make your projects really trackable is to use GitHub or something like that. Okay, so host your project on GitHub, and then what you do is you check in updates to your project periodically. So you work on your project. It can be a website, it can be a little app, it can be an Arduino project of some kind that you just have an interest in. It's okay. Okay, it doesn't matter what the nature is. The point is it has to be active, and whenever you interview, you can show the other person is like, okay, look at the history of this project. I keep on it. I make changes. I keep enhancing the project, and I keep debugging it, and so on. So that's actually important. But if you can get into internships, get into internships. Okay. Focus on cybersecurity and data analysis. These fields are rapidly expanding, and I would actually say that cybersecurity probably is a better option if you have to choose between these two compared to data analysis. The reason why I said that is cybersecurity is not quote unquote competitive, it is adversarial. In other words, if you get into, let's say, game programming, okay, so you can have all of these game developers or companies competing with each other, so they want to make a better game to beat the competition. So competition is kind of good from the perspective of employment because they all want to hire the best developers, right? But when the economy goes down, okay, and people don't have the excess money to buy extra games and whatnot, the game industry is going to go like like that, right? But cybersecurity is a whole different thing because it is adversarial, which means instead of having companies competing with each other for people who buy the games, they are actually competing, quote unquote, competing for survival. Okay, because they're trying to hack into each other's system, potentially causing massive chaos in the future. So I would say cybersecurity are if you get into cybersecurity, your job security is going to be more than in data analysis. Yep. Cultivate adaptability and continuous learning. That's just the way it's going to be. Okay, you have to be able to learn on your own instead of relying on taking classes. Now, I understand that at the beginning, taking classes is important. Okay, but at some point in time, okay, you really want to develop the ability to self-learn without the help of another person, because many times out there, in the job, you will be asked to learn something on your own. Your boss just tells you what needs to be done and not how to do it. And there will be individuals, your colleagues, your peers, who will be able to do that on their own. So you want to make sure that you have that ability as well. So anyway, I can share this with you if you're interested. I can put it into the announcement. So there's that. But we now get back to this thing here, not off-road driving. Okay, as much as I want to teach that, I really do not know much yet. So we'll go back to what I want to do today. Okay, um, one thing that is challenging for me is to come up with examples. Okay, that is appropriate for my classes in order to explain concepts. So this is what we're going to do today, is to follow the lead of ChatGPT. It gave me a problem which I have already described in my own module. So let's go to my own module, which is partially done. All right, so this is illustrating the whole process of how to write an algorithm. We have already talked about control structures, conditional statements, loops. We talked about arrays. We talked about functions. And with functions, we also talked about parameters, return values, how to trace all of that. So we have basically the basic vocabulary to explain or to express algorithms, ways to kind of use a program to automate a process. So this is an example, and this class, has problem solving as part of the title. But I think, the word problem typically it has a negative connotation. So instead of, looking at your assignments as a problem, we can look at it as a task to automate, which is basically what programming is all about. It is about automating something so that we don't have to do it by hand. The first step we need to do is to understand what is the input of an algorithm. In other words, what kind of information is already given to you to begin with, and what are the properties of the things that you are given with. Okay, so that's the first part. So we'll start with this kind of uh, this particular homework assignment or this programming assignment, for myself. This will probably take like 1 or 2 days to kind of explain and finish off, but it's important to understand the process. So I'm saying that I have an array called IDs, okay, which are, and each element of this particular array corresponds to the ID of a student. All elements of this array are unique because no two students should have the same ID. Is that okay? But you can see I put in parentheses, what does unique mean? Okay, in this context, so if you are looking at this word unique and they go like, well, I can see, I know what unique means in a general sense, but in this context, I'm not 100% sure what that means, then you need to find out what that means. So can someone tell me what unique means in this context? Nope, has nothing to do with the ordering. Yep. Exactly. You do not have duplicate items in the array of the same value. Okay, well, that's duplicate itself because in other words, no two elements of the array should have exactly the same value. That's what unique means in this context. Is that okay? So when you have a homework assignment in CISP 360, the first thing you need to do is to make sure that you understand what is given to you. And every word that is used to describe the input, if you're not sure, you need to ask for clarification. Are we good with that? Okay. And then the next one is you also have a different array called scores, where each element is a real number or real value from 0 to 1. Okay, I put in parentheses again. What does that mean when I said a real value? In a mathematical sense. Yes, it is not an integer. So a real number is not an integer. So this is where, you really have to kind of look at the description and not really just read it on a superficial manner, because most people know what real means in a kind of conversational sense. Okay, it means it is not false, it's not fake, it is real, right? But in a programming context, real is referring to real numbers in mathematics. So did you guys learn about integers versus natural numbers versus real numbers versus rational numbers versus irrational numbers in high school? Okay, so real numbers would be all the rational numbers combined with all the irrational numbers. Okay? Okay, so now I just threw two more terms to you guys. What is a rational number? Two is a rational number. What about one third? It is. Yeah, one third is also a rational number. So anything you can express as a fraction where the numerator and the denominator are both natural numbers, it is still rational. So 22 over 7, which is what many people use to approximate pi, is a rational number. So what is an irrational number? Pi, okay, pi itself is an irrational number because the number of digits that you need to describe the exact value of pi is infinite. It does not end. So there are other things that are also irrational numbers, but we don't think of those as irrational numbers. I'll give you an example. The number of days in a year is actually irrational. Most people think about this and go like, "Oh, no, 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 no. We know that, right? 365. There are 365 days in a year." Not entirely true, right? Because every 4 years is a leap year. Then go like, "Okay, fine. 365.25, okay, which is 365 and a quarter, which is 1 divided by 4. That makes it a rational number." But no, that is not true either, because every 100 years is not a leap year. And then every 400 is a leap year again. So there's a certain pattern to determine whether a year is leap or not, because all of those rules are really there just to approximate the actual number of days in a year. If you think about it, what is a day? What is 24 hours? But what does it measure? Yes, so it measures the self rotation of Earth. So one self rotation is 1 day, right? What is a year? What is a year measuring? Yes. So are there any particular reason why one has to be a multiple of the other? Exactly. So the ratio between how much time it takes for Earth to go around the sun and versus the time for Earth to rotate around its own axis, there's no particular reason why it has to be a rational number. It's not a machine that is designed by someone. Okay, this is just okay. It just turns out that Earth is in a stable orbit, so we are not falling into the sun or getting further away from the sun. But other than that, the ratio between these two numbers is irrational. Okay, so anyway, getting back to the whole point of a real number. So from our perspective, from the programming perspective, a real number is essentially a number that can have decimal places. Okay, that's for the purpose of this class. That's one way to look at what a real number is a value that can have decimal places. So 1.256, that's a real number. 3.1415, okay, which is just an approximation of pi, I can call that a real number in programming. Okay, in the programming context, those are all real numbers. So in this case, I have an array called scores. Each value is a real number from 0 to 1 and indicates the ratio of points earned divided by the number of the points that are possible. So it's a ratio, and that's why it's going from 0 to 1, except for people who get extra credit, they can exceed 1. The position of elements of this array corresponds to the IDs array. This means score 5, in bracket 5, is the score earned by the student corresponding to the ID of IDs 5. So does everybody understand what the last statement is trying to tell you? Yep, go ahead. So IDs is an array. It contains the ID of a student, of students, right? So IDs 0 is one student, IDs 1 is a student, IDs 2 is a student, and so on. Scores is also an array. So scores 0 is corresponding to the score of the student represented by IDs 0. Scores 1 corresponds to IDs 1, scores 2 corresponds to IDs 2, and so on. Okay, so once again, you have to make sure that you understand the statement or the description of the input of what you are given with, when you write an algorithm. So now we are moving on to the next statement here. Neither IDs or scores is sorted. In other words, we are not sorting by ID, we're not sorting by scores, neither is sorted. The only thing we know is every ID has a matching score, but the positioning of either array is not sorted. You cannot rely on ordering of any kind. Is that okay? Hmm? Okay, all right, cool. So now we move on to the next one, which is an array grades where each element specifies a threshold of a letter grade. So the first thing is, do you know what letter grades we are talking about? Okay, so letter grades corresponds to A, B, C, D, F in the United States. Okay, but letter grades are not necessarily A, B, C, D, F. In many other countries, they are not using just A, B, C, D, F. For instance, in Hong Kong, for the high school exit examination, they have A, B, C, D, E. Those are all passing grades. F, G, H are all failing grades. In other words, they don't have just one failing grade. You can get a you can get an F, which is you barely failed. Okay, good, better luck next time. Then you can get G, which is you are definitely failing, or you can have H, which is like you are failing within the failing population. You are failing like totally in a very bad way. Yeah, that's the letter grade system that the people in Hong Kong use for the high school exit examination. So they do make differentiation even within the failing. They still have to differentiate. It's like, did you just barely fail, or did you fail really really badly? Yep. All right. So in this case, I also give you an example, right? So the minimum score to earn a letter grade of D is going to be grades 0 because that's the first threshold that I need is, okay, what is the ratio that I need in order to get a letter grade of D? In most classes, this is not one of those. It would be a zero point 0.6. In other words, you need 60% of all the possible scores in order to get a letter grade of D. Anyone who's getting less than 60% is getting an F. Okay, but that is not how this class is arranged. Grades 1 is the minimum score to earn a letter grade of C or better. So that in most classes is what, 70%? And then a B is 80%, and an A is 90%. Um, and why do you think those are all kind of really square values like 60, 70, 80, and 90%? There are no particular reason. I can just tell you that there are no particular reason. They are really just more or less square values that people choose to use. Um, and that's why I don't use those because they're pretty meaningless to me. All right, so do we have any? Oh, there's one more. Okay. There's an integer also given to you. In other words, the value is already known ahead of time. It is called num students, which indicates the number of students in a class. The arrays, IDs, and scores have num students elements. So those two arrays have exactly this many students in each one because each element in each one of those arrays is representing something about a student. So are we doing okay so far with the description of the input? Go ahead. Yep, 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 exactly. So typically in this semester, I use n to represent the number of items in an array. But in this one, I want the name of the variable to be quote unquote self-documenting, which means when you look at the name of the variable, it kind of tells you what it is about. So that's why I changed the term from n to num students. So it kind of spells out what it is representing. Okay, all right. So generally speaking, this is what you need to do. Okay, the first task before you write a single line of code is to understand what is given to me and do I really understand all the things that are given to me and what each one is representing. If do they have constraints? Is it sorted? If it is it sorted in an increasing manner or is it sorted in a decreasing manner? If it is an array, can I have duplicate items or it has to be unique? So you have to understand all the constraints that apply to the input. It's not just what each item is representing, but also the constraints that are explicit that you can rely on. Because if I have arrays that are sorted, I can apply binary search. But if the array is not sorted, I cannot apply binary search. So knowing whether certain constraints apply to the input can affect how you write your algorithm to solve a problem or to automate a task. Are we doing okay? Or do we have questions? Okay. So then we move on to the output, which is basically describing, okay, these are the input, but what is the program supposed to do about the input? So the output is not really just describing the output, it actually describes what the program is supposed to do as well, which is also equally important. Okay, I would not say one is more important than the other, because without understanding the input and you just understand the output, what are you going to do? You don't even know what you're given with. And understanding the input but not understanding the output is like, okay, fine, you know what is given to you and all the constraints apply to the input, but where do you go from there if you don't know what the output is supposed to be? So the output in this case is going to have an array called grades. So that's the name of the array, where each element of the array corresponds to the actual letter grade of a student of a matching element of the same index in the ID's array. A value of 0 means a letter grade of F, etc. Because I haven't really taught you guys how to use characters or strings, so we cannot use A, B, C, D, F. So I'm going to use 0 to represent a letter grade of F, 1 to represent a letter grade of D, and so on, which is fairly easy to remember because that's also how GPA works. Okay, GPA, I mean, all of you know that already. A 4 means an A 3 means a B, and so on. I need a real number, so once again, real number means something that can have decimal places. Um, I need a real number called average. That is the mean of scores in the class. How many people know what that means? What is the mean? Yes, go ahead. Average. Okay, so how do we calculate average? Yep, that is. Yep, exactly. So knowing that definition of either average or mean, because they actually mean exactly the same thing, mean is more used, in a mathematical or statistics context to basically spell out what average means to the rest of us. Okay, so average is add up everything divided by the number of people, and you have the average. Is that okay? All right. So as you go over the output, you have to kind of think in your mind, if I were to do this manually, do I know how to do it? Because if you are to do this manually and you go like, I don't even know how to do this with a calculator, then you need to look a little bit deeper and understand, okay, what does that entail? So that brings us to the next item, which I think probably half the class do not understand this one, but I specifically want to choose one that you guys do not understand because then I can show you how do you look it up. So another output of this program is called SD, which stands for standard deviation of scores in the class. So did you guys take any statistics classes in high school or before this class? Some of you may, okay, some of you might have taken the class. Those are really useful classes, by the way. Taking a statistics class is going to be helpful because it is the entry point to data science. Okay, we saw data science is one of the recommended things for people uh, to study in order to become competitive. So if you don't know what standard deviation means, and you are asked to compute the standard deviation, what are you going to do? Mm-hmm. Yep. And how do you look it up? Okay, so the most important, I mean, most people just go by, Google search, which is not a bad starting point. Okay, it's okay. So you can say, what is standard deviation? Okay, and Google, these days, can actually give you an explanation, an AI explanation. But the first link is to Wikipedia, which is not bad. Okay, Wikipedia, I'm sure you have taken classes where the professor says, oh, don't go to Wikipedia. It's not a really reliable source of information. When it comes to politics and things that are opinionated, I would agree. Okay, Wikipedia is not the best resource because anyone can write anything about any subject. Okay, on Wikipedia, and competing sides can go like, I'm gonna overwrite yours. Okay, with my opinion and so on. But on things like this, okay, on standard deviation, mathematics, programming, technology, and stuff like that, I don't think you'll run into those problems. And standard deviation, unlike certain features of Windows, Linux, Mac OS 10, and so on, it is not new, okay? Standard deviations has existed, or we have this concept of standard deviation for hundreds of years. So the chances of, oh, there's a new update to this topic and Wikipedia has not been updated to reflect that is zero. Okay. So it is not a bad resource. Okay. It is actually not a bad resource, except there's one little thing about Wikipedia. It can be a little more than what you need. It will give you like a 20-page, description of standard deviation, including, the history of standard deviation, who came up with this idea or the precursor of this idea, and who further developed this idea, and what this concept relates to, and so on. It's great if you have the curiosity and want to find it out, no problem, it's good. But if you really just want to get a job done, that can give you a lot of distraction, So that may or may not be the best way to do it. So I'm gonna stop this here because it's not going anywhere. Chat GPT or LLM is actually not a bad way to do it either, okay? Because the thing about LLM in general or AI in general is, what is the biggest complaint that people have against using LLM? Okay, you need to confirm, right? And but there's a term that is floating around a lot when people complain about, oh, you should not be using AI because of blah blah blah. Okay, what is that? Hallucination. Hallucination. Meaning, the AI is giving you something that is not actual. It's not real. Mhm. So that can happen, depending on the query, depending on many factors. But when you're talking about things like standard deviation, that's not going to happen. Okay, it will give you a correct answer. So I'm going to start a new chat here, and I'm just asking, Chat and GPT in this case to say, what does standard deviation mean in statistics? Okay, it can even finish its own sentence. Okay, there we go. Okay. So that means, so would you like a formula or a simple example? Yes, give me the formula. Okay. And don't add please, okay, as much as you want to be polite, because that's just gonna use extra water to cool down the computing hardware that is not necessary. Yeah, I have a tendency to use please or you, as if I'm talking to a person. But according to Sam Altman and the other CEO, the CEO of Anthropic, they said, these words, they're extra, that really serve no purpose. They just, use up extra water for cooling the systems. Um, all right, so it gives you a formula, okay, which is great. But what does that mean? Okay, what is x of I representing? What is mu, which is a Greek letter representing? What is n? And this is sigma, which is basically what people use to represent standard deviation. So just kind of scroll a little bit here. So it tells you something about population standard deviation, which means there's a standard deviation that is not the population standard deviation, but we're not too concerned about that. N is the number of data points. X of I is representing each data point, and mu is the population mean. So that means in order to understand what is standard deviation, you first have to understand what is mean or average in this case. The nice thing about LLM is you can ask for clarifications. So you can now say what is sample standard deviation as opposed to population standard deviation. So if the question that is given to you, if I describe your task is, oh, I want you to give me the standard deviation, and I did not say what is the population or the sample standard deviation, then what are you gonna do? Ask the person who gave you the task to begin with. Okay, you go like, okay, there are two standard deviations. One is called population standard deviation. The other one is called sample standard deviation. Which one should I compute? They're only off by a little bit, okay, because one is divided by n, n representing, in this case, the number of students. The other one is divided by n minus 1, okay? So which one am I supposed to use? Ask the person who gave you the task to begin with. Okay. So you can also, go to, ChatGPT if you are interested in knowing that. Is you can ask what is the difference between a population standard deviation and a sample standard deviation. Okay, so if you're curious and you really want to know, why there's a difference and what the difference really is about, you can ask those questions. And this is something that is not easy to do with Wikipedia, because Wikipedia gives you a static page, and it probably has a whole section that talks about what is a population standard deviation as opposed to what is a sample standard deviation, how they're different, what they really represent, blah, 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 blah. Okay, but you have to read the whole thing, or at least locate that section to read it. With LLM, you can interactively ask for clarification, and you can expand on certain things. It's like, okay, what is x of I representing in the notation? Or, how do I get to the mean? How do I calculate the mean? And so on. So from that perspective, I would say this is the first thing I would encourage everybody to experiment, is to use LLM for your studying. Okay, don't use it to do your homework. Okay, but use it to explore things that you need to learn. Well, you don't want to ask it to problem solve for you. You want to have your LLM to help explain concepts to you. Yeah, because sometimes I have a tendency to explain things in a very terse way. Okay, does anyone know? Yeah, what is terse? TERSE. What does it mean? Okay, so that means we should look that up, right? So, okay, that's a pretty easy one to look up. Any dictionary will do that. So in Google, you can say define terse, okay, with a colon. So it will force Google to go into dictionary mode, and kind of give you a very terse explanation of terse itself. Okay, terse means um, essentially use the least number of words to do something, being concise. And it's not just concise, it's being concise to the point where people think, okay, can you expand that a little bit? Okay, even though what I said contains all the information already, but it's not presented in a way that is easily digested. Is that okay? Okay, so that's what terse means. So I have a tendency to make things really terse, to be as concise as possible. And most other people do not learn from terse material. They want examples, they want things to be more expanded. So this is also how LLMs can be handy because if I explain something in a very terse way, you go like, okay, I'm not really quite sure, what this means. I need some explanation. I need this to be expanded. You can actually ask an LLM, okay, upload my content, upload my notes, my modules, and whatnot, and then you can ask specific questions. It's like in the context of this particular module, what does this sentence actually mean? Can you expand this or give me examples? That is also a way to use LLM for studying, which I think is really helpful for many, many people. Is that okay? All right. So I'm actually quite I'm trying to explain multiple things at the same time, which is also a tendency of mine. So now we continue to read this. Okay, bonus, good to have, but not necessary. So this is kind of like, okay, if you have time to do this, you might as well do it too. I also want an array called ranking, where each element of the array corresponds to the ranking of a student of a matching element of the same index in the ID's array. In this context, rank 1 means the highest score, rank 2 means the second highest score, and so on. Okay, so I just want a third array. In this case, this is actually the fourth array, so that I can, no, fifth in this case. So I want this array to give me the ranking of students. So I can actually see, okay, who's rank 1, who's rank 2, and so on. But it's not needed. All right, so do we have any questions about what you're given with and what you need to produce, with your program? Any questions about that? All right. Okay. So you have a lot of things you have to do, right? A whole bunch of stuff, okay? I have to calculate the standard deviation, I have to calculate the mean, I have to do blah, 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 blah. Okay, so where do you start? Well, most people would tell you, oh, use top-down programming, okay? How many of you have heard of the term top-down programming? Okay, so top-down makes sense, okay, in many, many cases. How many of you have taken an English writing class? Okay, yes, go ahead. Oh, you have taken a writing class? Okay. So in an English writing class, they give you, let's say, an essay to write. They give you a certain word count, right? So let's say 1,000 words, which is not terribly long, kind of long, but not really long. So if you have to write a 100-word article or something about, just pick a topic, pick a topic of how inflation is going to affect your daily life. Okay. Very simple stuff. Are you just going to sit down and write from the beginning all the way to the end in one single stroke? So what do you do? Mm-hmm. 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 All right. So are you going to keep all of that in your head? It's like, okay, now I'm going to explain what it is. Now I'm going to tell people how it affects my life. And now I'm going to tell people a conclusion. So you're not going to keep it all in your head. So what will you do instead? Let me have. Mm-hmm. Right. Mm-hmm. Yep. So you're using a technique that we call starts with a O. Yep. Mm-hmm. Mm-hmm. Hmm. Hmm. But are you going to keep track of all of that in your head? It's great that you know how to structure the whole thing, but are you going to remember the whole thing throughout the writing of this article? You have to do it in sections, right? So how do you remind yourself that, oh, I need a section to at least first explain what inflation is in this context, what is leading to inflation right now, and so on and so forth. So how do you keep track of all of that? As I said, there's a term that starts with the O, outlining. Okay, outlining, which is kind of using just a bulleted list. Okay, kind of it is nested, right? So you have more indentation, as you move into the details. So you use outlining to remind yourself the overall structure of the article is not going to be the actual output, right? You're not going to give your professor the actual outline, but you use the outline to kind of keep track of, okay, I need to work on this section now. I'm going to expand to more details in this section, and then you can keep adding more bulleted lists or nesting of the bulleted list until you go like, okay, I think there's enough information for me to actually write about, and then at that point you start to convert the bulleted list into sentences, right? So that's called top-down design. Okay, you use an outline to keep track of, okay, overall speaking, I need these four sections: introduction, blah blah blah, and then all the way to summary, right? And then you look into introduction itself, and then you ask, okay, what is my target audience? What do I need to do to explain or introduce inflation? Okay, then you go into like, okay, what is the definition of inflation? What is the current inflation rate, and what is the historical inflation rate, and how, why this is important. Those all go into the introduction, and you go into each one of those and you say, okay, how do I expand this, right? How do I explain what is inflation? Do I want to explain this from the actual economical perspective, or do I want to explain it in more layman's terms so that people can easily understand and digest it, right? Because you can always say, okay, remember, how much gas cost 10 years ago per gallon, and how much does it cost now per gallon? Okay, how is that ratio corresponding to your income ratio? Okay, assuming your job has not changed. So, so you can use all of those things to help explain things, but you're using an outline mode. Okay, you're starting with the overall architecture or structure of the code or the article, and then you move into more details. So this is also how many people recommend people to write programs. Is to start with the overarching thing of what you need to do, and then kind of move into the details. I have a problem with this approach. The problem with this approach is it's not almost impossible to test your program as you write it. Okay, which is a big thing for me because you, especially when you're starting out in programming, okay, you kind of want some confirmation, like, okay, I'm just going to do a little bit here and I want to double check this is working, and then I now have a reliable piece. Okay, it doesn't do much, but I have something to build on, and then I build a bigger block, I test a bigger block, and then I make an even bigger block, and then I test that block. So that approach is called bottom up programming. Okay, because you're starting with the details. Um, Most people do not teach this type of programming technique, but from the perspective of debugging a program, in other words, making sure your program works without any bugs, this is the best way to do it. Okay, it's bottom up. Yeah, from the details. Okay, you find one very specific small task that you have to do anyway, and then you just figure it out, and then you test it, make sure it works. Exactly. Yeah, because top down sounds really good, but when it comes down to the actual practice of top down, especially in programming, you can't really test your program on gradually, which to me is a big problem, right? Because when you're writing an article, there's no debugging, okay? Because debugging when it comes to an article, it's more like, okay, I'm just going to fix some grammars, fixing my punctuations and whatnot. Um, if you use like a word. Okay, so in a context when you're trying to describe something that is contrasting and you use the word and, but you really, it's better to use the word but, okay, and you use the word and, do you think the audience will still be able to understand your sentence? Yeah, they don't have a problem, except it doesn't have the same dramatic effect, okay, as the word but, right? But when you have a problem in programming, even though most of the code seems to be correct, and you make one tiny little mistake somewhere, it's not going to work. And to find that problem, find that little bug and fix it can be very difficult. Okay. So the way I do programming is bottom up. So now in the bottom up approach, you look at all the things that you need to do. There are many, and you go like, okay, I'm gonna pick one that is easy for me to tackle, and it'll be easy for me to test it also. So of all of these things that I need to do, I'm gonna say, okay, given a particular score, how do I find the actual letter grade? I'm gonna start with that. Okay, I'm not going to start with calculating the average. I'm not starting with all of the other things. You can, okay? There are many places that you can start. In a programming task like this, there's no right or wrong answer here. I'm just going to show you what I would do, right? So the way I would do this, okay, which I'm going to document over here, okay? This is the same document except it is in the source format. So this is how I actually type, the notes here. So I'm going to use a bottom up approach. Bottom up approach, starting with um, a function that computes the letter grade. I put in quotes because we are not actually using the letters. We're using 0 to represent F and so on from a score and an array representing the thresholds of grades. Okay, so I will give myself this particular task, okay, writing just a function. So, okay, now that I know this is my starting point, what do you think is the next thing I need to do? I have chosen a particular task as my first task, so I need to better define, what this function is going to do. So with any function, can someone tell me, some of the properties of a function? Okay, properties of a function. Yep. So we have parameters. Okay. So we got parameters. Okay. What else? Hmm? Placeholder. Okay. It's related to placeholder. It is the return value. Okay. All right. So you. So this is good. Okay. This defines the interface to a function. In other words, from outside of the function, from things from the caller's perspective, these things will basically define what it takes to call the function and what is the value representing when it returns. So we need to kind of expand this a little bit more. Okay, so what do you think are the parameters that we need for a function like this? Okay, given the function, the task of the function is to compute the letter grade. So what do we need? It is already partly described from here. So we need a score, right? So a score from 0 to 1 is going to be one of the parameters. What else do I need in order to determine, oh, this is a score of 0.725 and it should be corresponding to which grade? What else do I need to make that determination? Remember, one of the inputs is an array of the thresholds of the letter grades. I need that, right? Okay, so I need an array of thresholds of letter grades. Okay, and anytime an array is the input to a function, what else do you need? Do you remember when we pass an array to a function, it is always passed by reference. Very good. And that reference is only referring to the first column of the array. Does that also tell me how many items are in the array? No, that is correct. Okay, it does not. So that means I need one more parameter to tell me how many items are in the array. Okay, so that's what I need here. Okay, so I need another parameter here, which is the number of elements in the threshold array. Okay, I think that's all I need. Okay, yep, go ahead. hmm You can make assumptions, okay, but assumptions are like this kind can be dangerous. So let's just say that you make the assumption. So you can make an assumption that the score can only go from 0 to 1. And then you make a further assumption that the threshold um, is going to terminate with a value that is at least 1. So that means when you get to that point, oh, okay, this value is greater than or equal to the highest possible score. So as a result, I know that has to be the end of the array. So you can use this is what we call a terminating condition in an array, is you have a special value in the array that indicates this is the end of the array because it doesn't make sense to be a part of the actual array. Because if you think about in this context, if the score can only go from 0 to 1, which is corresponding to 0% to 100%, and then you have a threshold that says 200%, it's like this threshold does not make sense. So that makes that particular threshold value usable as what we call a terminator, because that particular value says you can stop here. There's nothing usable past this point, or you really should not be getting past this point. But it leads to um, security vulnerabilities. Whenever people make an assumption like this, like there's a special value that has to be the last thing in the array, then you're always running into issues of what if it doesn't happen? Exactly. What if someone forgot about this terminating condition and they gave you an array that does not have the correct terminator? Then you have a problem because now you can have many memory locations that might correspond to values that are less than 1. So you'll be traversing memory locations that you're not supposed to. In this case, it's not too bad because you'll just be reading those locations. You're not going to be overwriting the locations. But in the cases where you might even overwrite locations, then you have a problem because you can overwrite locations in memory that you really should not be overwriting. And that can lead to a whole bunch of other problems down the line. So it is always to use an explicit length to terminate and go like, we know there are only, let's say, we have A, B, C, D, because you don't need a threshold for F, right? So we only have up to 4 items, and you make it explicit as its own parameter. It is always safer that way. All right, so now I know the inputs to the function. Now I need to describe what the output is representing. So the output, which is the return value of this function, is just going to be the index of the last threshold that the score is greater than or equal to. Does that make sense? Okay. And this is also already having an assumption, which is the thresholds are sorted in an increasing manner. Okay. So that also needs to be made explicit because if I don't make it explicit, some people may say, oh, but it makes more sense where the first item is the threshold of an A, the second is the threshold of a B, and so on. It actually does make more sense that way, by the way. So um, so we want to kind of add to this. This array is sorted. This array is sorted in a non-decreasing manner, okay? Which is, increasing here because it doesn't make sense to have two identical threshold either. But, this is just one way to describe it. Are we doing okay so far? So when I just focus on one little task, I then look at that one little task, which is described by line 36 of the text document. I further explain, what the function is about, what are the parameters, what do we know about the parameters, and what is it returning? Okay, what is that value representing? So are we doing okay so far? Okay. So now I can finally get into the whole thing. It's like, okay, let's go ahead and write the logic of doing this. All right, so we'll go ahead and focus on the logic. And I'm going to make this one a little bit more centered because I'm actually putting the code here. What I'm doing here is using what we call Markdown to actually capture the code here. Markdown is a play of the name. It really is a markup language, but because it is simple and easy to understand, they just call it markdown instead of markup. So it's really just a play of the name. So whatever I put between the backtick, backtick, backtick C and the backtick, backtick, backtick here is going to appear as syntax highlighted C code in the finished document. So this is what I'm doing here is I'm just trying to capture the whole process of writing this function right now. How should I call this function? You would go like, it's just a name. It's probably not important. What do you think? Is it important to choose a particular name for a function, or do you think it is not important at all? I'll just call my first function f1, the second function f2, and so on. Yes. hmm Exactly. Yep. Ex yep. So you want the name of the function to suggest what the function does. Yep, that's exactly right. Because if that is not important, I can name a function underscore underscore underscore. You guys cannot see it. And the next function is four underscores, and then the next function is five underscores. You can actually do that, okay, if you want your program to be basically unreadable. Um, but no, that's not what I'm gonna do here. So I'm gonna say this is you can make it score to grade. I know it's really hard for you to see because I can change the setting of GitHub, or I can just use a different editor. Let me just use a different editor for now and start a new document. Here we go. Hide this one. All right. Okay, this is a lot better, easier to read. So I know the return type is an integer instead of a void because I'm supposed to return the index of something. The index of an element in an array is always going to be a non-negative integer, which is still an integer. So I use integer as the return type. And I'm going to call this one your score to grade. So this particular way of naming something using a mixture of lowercase and uppercase, having the first letter being lowercase and then use an uppercase for the for the first letter of each word is called, as you said, camel casing because it looks like a camel, with the hump. Okay, so this is called camel casing. And you might be asking, is that really important? Can I just use underscore here everywhere that is supposed to be a space like this? The answer is yes. From the mechanical perspective, this is also a valid identifier, but most employers will basically say, okay, I want you to use camel casing for the functions or variable names and whatnot. And you go like, well, that's kind of too much dictatorship. Okay, why do you care about how I name my functions and variables and whatnot? Well, the answer is what? Why do you think your employer cares about your the style that you use to write your code? Why do you think that is important to your employer? Hmm? So that you could read it, but you say that the employer. Well, your employer, your boss, is not very likely to have to read your code. But are you planning to work for that company like for your entire life? No. Most people stay with a company for maybe 3 to 5 years. Okay, it really depends on the era. Like these days, it's not going to be even 3 to 5 years. In the golden days, okay, in the golden days, which is I'm referring to the 80s. Okay, typically people would work, especially with certain companies like HP. That's kind of like a lifetime employment. Okay, because HP used to treat their employees really, really well. Okay, so let's just say that I got into a certain section, that's my first job, and I suck at it. Okay, what do you think is going to happen to me? At HP in the 80s, nope, they're not going to fire me. They basically have a policy of never to fire an employee. So instead, they go like, Tech, I can see that you're not really good at database programming. But we have that the sections over there. They write printer drivers. So why don't you give it a try too? So let's say I also suck at printer driver development. Then go like, okay, I see this is not working out for you either. Let's try this. How about you write test programs to test our calculators because they used to make calculators. So they're going to move me around the company until they find my spot. Okay, something that I'm really good at. That's what HP used to be. Not anymore. Okay, that is not the thing. For I think for at least a decade or two, they have not been doing that anymore. Hmm? Well, part of it has to do with the product line has changed over time, and then part of it has to do with basically the culture of technology companies have changed over time as well. There used to be a company called SGI, which stands for Silicon Graphics Incorporated. Most of you do not know it because that company was bought by, I cannot remember which one. I think it's Radeon or the company that made Radeon, the graphics cards. And then that company in return was bought by AMD. So, that's why SGI, most people do not know about SGI anymore. So when SGI was around, the company policy was there's no start time of the day, there's no end time of a day. They have showers in the facility, a gym with showers. So people just kind of show up, quote unquote, whenever they want to. And this is before remote working either. Okay, so if you want to work, you have to be on campus, right? They get paid based on their salary, right? It's monthly. It's not based on actual work produced. Because back in those days, if you are in computer science, most people are already passionate about what they do. You don't have to crack the whip. You don't have to give them the stick, okay? Because intrinsically, they already have a carrot hanging in front of themselves. You don't the companies don't even have to hang that carrot because these people come with the carrot already hung in front of them. So they go to work every day. It's like, woohoo! I'm going to work. Okay, what kind of cool things am I going to do today? Okay, so most people go to work a little bit late because most of these people they go to bed late because they got a lot of things that they want to do. So they go to work. They show up at about 10 a.m. or so. Okay, unless there's a meeting, then they have to show up on time. But regularly, they just go like, I go to work whenever I wake up. Okay, and traffic is not too bad. Then I drive to work and then they work until they think they are done. Okay, and that typically is like 7 p.m., 8 p.m., or so on. Because they're having fun. They don't notice the passage of time. So that was the culture back in, I would say, the 70s, 80s, and even the 90s. That's how these high-tech companies in Silicon Valley operated. Okay, these days, completely different. Okay, the culture has changed. The kind of people who work for the companies have changed, and so on. There's remote working. Okay, there's COVID, and what some people have noticed is some people exploited remote working, and so instead of having one job, they have three jobs, and they try to not work as much as possible, and that's how they can handle like three simultaneous jobs and get paid with three different salaries. Okay, um, and I can tell you that some of my colleagues at the community college, they do the same thing. They teach at multiple community college districts, simultaneously as full-time professors. They get paid full-time professors in multiple districts, and then what? Because they teach online classes. If they teach face-to-face classes, there's no way I can do that, right? Just physically, I cannot be at multiple places at the same time. And at the end of the day, I'll be drained, okay? Because I mean, I know teaching sounds like it's super easy and you don't expend a lot of energy, but it does, okay? It does. I do expend energy. But if you're teaching online asynchronously, and all the material that you're teaching is from an online textbook that the publisher has already prepared. It has all the assessments already done, and everything can be graded because they're all multiple choice. Because when you turn in your homework assignment, I actually have to read your spreadsheet, cross-check that against what the answer is supposed to be, and then I have to go like, how many points should I give this particular submission, and so on. So everything is manual. But with online textbooks, they're all automatic because they intentionally give you only things that can be graded automatically. So imagine, a class where this is all you do. You have a textbook that is online. All the assessments are online. They can all be graded automatically, right? So when do you ever have to contact the professor? When you don't turn your homework assignment, you just get like no points for the homework assignment. The professor really does not have to initiate any contact with you. So that's how people can take on multiple jobs simultaneously and get paid multiple times, okay, as full-time employees. So I'm not even talking about, oh, I'm just going to pick up a little part-time job, on the weekend. Nope, nope, multiple full-time jobs. And that's what is happening now, okay? And I think companies are now starting to realize that many of the software engineers are not producing any work. I think Stanford University actually did a research, I think at the end of last year or the beginning of this year, of a high percentage of software engineers who work remotely are producing nothing. They're not underproducing, they're producing nothing. You can do some research on that, but it's interesting to know, why things are the way they are. Mm, all right, so I'm just going to, I know we are quickly running out of time, but I'll finish this part first, okay? So we have num thresholds. All right. So this is the outline of the function that I'll be writing on next Monday. Okay. So I want to really show you, the process, and I did not prepare anything ahead of time today. And that was intentional because I want to show you exactly how I would tackle this problem, you know, in that sequence, right? Because that means I'm not just reading off of some textbooks. This is actually how I do things. Okay. So this is defining the basically the outline, or not so much the outline, but the interface of the function that I'm going to write. This is new to us, okay? So when someone gives you something like this and you go like, we haven't seen double before, ask that question, okay? Asking questions in your classes is really important. When you see something you don't recognize, I don't think we have dealt with double before, ask questions. So double is the name of a type. Like integer, it is the name of a type, except double is representing real numbers. The full name of double is this. It's called double precision floating point numbers, and there's a Wikipedia page corresponding to it. You don't have to read it, okay? So don't go there. You don't have to do it. But basically, the name or the term double is telling you that score can be a number that has decimal places. That's basically what you need to know from in the context of this exercise is now we know score can be a number with decimal places. It can be 0.25, it can be 0.755, and so on and so forth. So that's it's a different type compared to integers. So everything you can represent using an integer can also be represented by a double, but not the other way around, because a double can represent things with decimal places. And the score is certainly something that has to have decimal places, because a score is a percentage, it is a ratio, it goes from 0 to 1. Okay, so it has to be able to represent decimal places, and then the thresholds are the same, but except in this case, what is this doing here? What is the square brackets doing here, and what is it indicating? It is an array, exactly. The parameter itself is an array, and the number of items in the array is my last parameter here. It is the number of thresholds. Okay, so we will continue with this on next Monday, but if you want to give it a shot and just go like, okay, I want to do this as much as possible, okay, go ahead, okay. It is going to be useful, okay. It is to kind of have you guys to think about, okay, if I were to do this, how am I going to do it, okay. It's the process that is important, okay. Because when you go through the whole process, you're basically strengthening your reasoning skills, you're strengthening the problem solving skills, and so on. So it is about the process. It is not so much about the end result. The end result is easy, I will tell you this, okay. And and I know some of the other professors down the line is going to hate me. Every homework assignment that you ever need to do in any programming class at this level can be done using AI. Here, I said it. Okay, so you can take the homework assignment description of any class. I'm talking about all the way up to 430 here. Okay, you copy and paste it into a LLM. It just let it rip. Okay, it will give you the answer. Okay, so the idea is not about the destination, it is about the journey. Okay, it's about the journey, it's about the learning that you're going to do as you do it yourself. Okay, because it is only through that process that you will discover that oh, I can do this that the AI cannot, because that's going to be the focus if you want to get hired. All right, so I will see all of you next Monday. Have a nice weekend, and you have about 5 days to kind of chew on this one, okay? And then I'll talk about this on next Monday with my approach of how to write this code.